Hello and welcome to InsideWi-Fi, Video 40. Subcarrier arrangement in 802.11n or AC, 40 MHz channel. Let's visualize how subcarriers are structured in 802.11n or AC, 40 MHz channels. Total subcarrier allocation for a 802.11n or 802.11 AC 40 MHz channel are 128, which constitutes data subcarriers, pilot subcarriers, guard subcarriers and null subcarriers. The subcarrier spacing for a 40 MHz 802.11n or 802.11 AC channel is 40 MHz divided by 128 equals 312.5 kHz. Data subcarriers. Data subcarriers are responsible for transmitting the user data. Each data subcarrier carries a portion of the total data being sent over the wireless channel. There are 108 data subcarriers in 802.11n or 802.11 AC 40 MHz channel with indices at -58 to -2 and at 2 to 58 excluding 6 pilot carriers. Pilot subcarriers. Pilot subcarriers are used for channel estimation and synchronization between transmitter and receiver. Pilot subcarriers carry specific training sequences in certain data demodulation. There are 6 pilot subcarriers in 802.11n or 802.11 AC 40 MHz channel with indices at -53, -25, -11, 11, 25 and 53. Null or DC subcarriers. Null or direct current subcarriers are used for identification and are located at the center of the spectrum. The center subcarriers provide a distinctive notch which can be easily detected by a receiver to begin synchronization. There are 3 DC subcarriers in 802.11n or 802.11 AC 40 MHz channel at the indices -1, 0 and 1. These subcarriers are inactive. Guard subcarriers. The first 6 and the last 5 subcarriers totaling 11 are guard subcarriers used to reduce interference from adjacent channels. A guard subcarrier carries no data. These subcarriers are not modulated and remain inactive or null and act as insulation for nearby transmitters that are using consecutive, non-overlapping channels. The guard subcarriers in 802.11n or 802.11 AC 40 MHz channel are at indices -59 to -64 and 59 to 63. In our next video, let's see subcarrier arrangement in 802.11n or AC, 80 MHz channel. Thank you for watching.